Hello everyone. In the previous video, we talked about what are the good characteristics of a forecast, and what are the best practices when we try to put a forecast together. So in this video, we are going to talk more about two important quantitative forecasting methods. So the first one is the naive approach. The other one is going to be the moving average method. And the moving average method is going to have another variant. It's called weighted moving average method. So let's get started to understand what really a naive approach is. It is very easy to understand and detect a naive approach. So if you look at the description, it says that if they use a naive approach, they assume that the demand in the next period will be the same as it is in the current period. Meaning that today, if our sales is 50 units, and if you use the naive approach, your assumption is that tomorrow it's going to be 50. The day after tomorrow is going to be 50 again, right? So that's why this is called naive approach. Um, it might work in certain cases, right? If, for example, you are trying to put together a demand forecast for a very negligible item in your revenue. Let's assume that there is one product that is not really 1% of your revenue, and then you don't want to really spend too much time about making a forecast for it, then you can use this naive approach. Um, Having said that, while dealing with forecasting methods and methodologies, we are going to use this term, these two letters. Um, so F is going to be representing our forecast, right? It's going to be our forecast. And in the index that it comes with is going to be the time period that we are going to be making a forecast for. For example, if it is FT, then it means that it's our forecast for time t. So in this sense, if t plus 1, the forecast for the next time period, assuming that we are at t, right, is basically at, and a stands for our actual observation. Okay, so if t plus 1 is equal to 80, according to naive approach, meaning that, hey, the forecast for t plus 1 is equal to whatever you observed at the current time t. Okay, all right, so this is easy. It's pretty straightforward to implement. One additional thing that we can do just to improve this forecasting method is to incorporate not only today's observation, but also maybe yesterday's and the day before's observation into our equation, right? If you would like to consider that, then you would be implementing a moving average method. So in the moving average method, the key thing to consider is the parameter, meaning that how much further in the past you want to go back, right? Would you like to be using just today's and yesterday's value and average them out, and then present it as a forecast for your tomorrow sales? If that is the case, then you are using just moving average parameter equals to 2, right? Just 2 days or 2 time periods, whatever your time period is. But if you say, I would like to go ahead and look at the entire week in the past, then it will be, and if your time period is unit is days, then you will be going back 7 time periods before. And then averaging them out would give you your forecast. That's what this whole math is all about, all right? But the key thing to remember is that you have to select your n. It's basically, in this method, will be the number of time periods to consider in your forecasts. Okay, so then the moving average forecast for t plus 1, assume that we are at time that is equals to t. If I'm making the forecast for the next time period, the reason that we represent it this way because t can be day, t can be an hour, a minute, a week, a year. So t can be anything. If you assume that it is the day, then the forecast for tomorrow is going to be the actual value that you have for today, right? And the actual observation that you had for yesterday, right? And the actual observation you had for the day before yesterday, so on and so forth, all the way down back by n periods, you are adding them up and dividing it by n. It's basically taking the average of the previous n time periods. So let's see this in action. Here's an example. In this example, our t is actually week. Our time period is week. We are trying to make a forecast for the product, a weekly forecast for the product. And we observe our previous data point. So let's assume that my time period is from 1, 2, 3, 4, 5, 6, 7. I believe I have 8 observations, right? And then let's assume that these are my weekly sales, or this is simply my AT, right? These are already observed numbers for my individual weeks. So for week 1, for example, I had 14. For week 2, I had 9. For 3, I had 30. For 4, I had 22. And for 5, I have 34. For 6, I had 12, 19, and 23. And the question is, using moving average method with n is equal to 3, find one step ahead forecast for weeks 4 through 8. All right, so I will just include my FT, my forecasts here, right? When T is 1, it's basically trying to make a forecast for the first week, for the second week, for the third week, so on and so forth. Okay, that's what we're going to be doing. But the question is basically saying that by using the 3 most current observations, make a forecast, one step ahead forecast for weeks 4 through 8. Why not for week 1, week 2, and week 3? Why can't I make a forecast here, here, and here? It's because I do not have previous observations that I will be using, as an average to make a forecast for these weeks. I can only start making a forecast if n is equal to 3. I can only go back 3 periods and use these 3 as a forecast for time period 4. So what's my forecast for week 4 then? Well, it's easy because it's simply going to be 14 plus 9 plus 30 divided by 3. Okay. So that would be 44, 53. It is 17 point something. I'm sorry, I did not really calculate these numbers. And then my forecast for week 5. Oh, by the way, this is assuming that I just observed the value here, and I do not really know these values, right? So it's basically assuming that you are at the end of week 3 and you are trying to make a forecast for week 4, okay? Having the real value and still trying to make a forecast for that real value, it doesn't really make sense. If you have the actual observation, you don't really need to make a forecast for it. So this is just to check for in the future. In next week's class, you will see that you will have to calculate the error associated with each forecasting method. That's why we have to really actually make a one-step out forecast to see whether our method is performing well or poorly. But again, if you have the real value, you should definitely not make a forecast for it. You shouldn't really waste your time. This forecast would be assuming that we are at the end of week 3 again, and we observe these 3 values, observations, and then by using these 3, taking an average, pure average of them, you would actually make a forecast for week 4. All right. All right, let's keep doing the same thing for other weeks. So assume that now we are at the end of week 4, okay? And we are trying to make a forecast for week 5. By the way, this is my forecast for week 4, and this is my forecast for week 5. It will be simply by looking at the previous 3. In this case, this would be this 3. We would ignore 14 because now it is actually 4 period before our forecasting planning horizon, right? We would incorporate it in our forecast. So it will be 9 plus 30 plus 22 divided by 3. And our F6, our forecast for week 6 would be then just this 3. Okay, it would be 30 plus 22 plus 34 divided by 3. Let's keep going. So our F7 would be using these 3 numbers in the forecast. So F7 would be 22 plus 34 plus 12 divided by 3. Okay, and my F8 forecast for week 8 would be using these 3 numbers. It will be 34 plus 12 plus 19 divided by 3. And finally, I would like to make a forecast for week 9. I do not have any actual observation because this is the next time period, and I can still make a forecast for it because I do have the three most current data observation, 12 plus 19 plus 23 divided by 3. That would be my future forecast. Okay. All right. So what's my forecast for week 10? Right. And what's my forecast for week 11? I don't have any actual observations for these data points. It would be the same forecast that I made for week 9. You would still be using the same forecast that you made for week 9 as a forecast for week 10 and week 11.